Welcome to Curve Sketching Steps Part 2. So in one of the previous videos on curve sketching, we looked at it before we'd introduced derivatives. So we found domains, determined if they were even, odd or neither, x and y-intercepts and asymptotes and the behaviour near them. Now we're introducing a couple of extra steps. So the first one is we're going to find the first derivatives, and we're going to find the zeros and determine the nature of the stationary point. So whether it's a maximum, minimum, or a horizontal point of inflection. And then we're going to find the second derivative, and we're going to find the zeros as well for the second derivative. That'll find points of inflection or possible points of inflections, and we need to test those using a table of values. So here's our example. We got y equals x cubed minus 3x squared plus 1. So step one, we're going to find the stationary point and determine their nature. Then we'll find the point of inflection, and we'll obviously check the concavity to prove that it's a point of inflection. And then we'll sketch the graph showing all the features, and we'll include the y-intercept. Now this one's a bit difficult to find the x-intercepts, but sometimes you can be asked to do that as well. So we'll just start with the domain and look at the asymptotes. So the domain covers from negative infinity to positive infinity because all x values work, and there's no asymptotes involved in this. There's no fractions involved. So step one, so when we find our stationary points, we differentiate. So y dash is 3x squared minus 6x, and the stationary points occur when the first derivative equals to 0. So you let that derivative equal to 0 and factorise, so that's 3x outside of x minus 2. That means that y dash has zeros at x equals 0 and x equals 2. So now we determine their nature. So a table of values. So remember, x equals 0 and x equals 2 were our stationary points. So they go into the table, and then we pick values either side of those. So minus 1, when you sub that into the first derivative, it's 9, so it's a positive slope. 0 is obviously 0 because that was one of our zeros. 1 is negative 3, so it's a negative slope. 2 is 0, so that's one of our stationary points. And 3 is 9, so that's got a positive slope. And as you can see, on either side of 0 is a positive slope, 0 negative slope, so that's a maximum turning point. And either side of 2 is a negative slope, 0 and a positive slope, so that's a minimum turning point. Now to get the actual value of y, you sub the 0 and 2 back into the original equation. Let's move on to the second derivative. So when we do the second derivative, we get 6x minus 6. So a possible point of inflection when the second derivative equals to 0. So you sub 0 in for the second derivative, and it has a 0 when x equals 1. Check concavity, so sub a value either side of 1 in, so 0 and 2 into the second derivative, and you get negative and a positive. So therefore the concavity changes, therefore we have a point of inflection at the point 1 minus 1. Finally, sketch the graph. And so the only thing we haven't found out of all of this is the y-intercept. So that occurs when x equals 0, and if we sub 0 in, we get y equals 1. Showing all of our features. So you can see we have a maximum at 0, 1, which happens to also be the y-intercept. We have a minimum turning point at 2 minus 3, and we have a point of inflection at 1 minus 1. Thank you.